Hello students, in our previous lectures we have already seen what the basic concept of higher order derivatives is. We have also seen some of the examples. Now in this video we are going to see one very important type of higher order derivatives which involves something called as a differential equation. Now differential equation is an entire separate chapter we have to see. We will definitely be looking into it in our other videos. So today we are going to now focus on this very important type of higher order derivatives. I welcome you all. My name is Pankaj Lade. Let's begin with this very important example of higher order derivatives. Now, if you look on the board, the question that is written is y is e raised to m cos inverse of x. So there is y given to us and it is e raised to m cos inverse of x. So you can observe from here that y is an explicit function of x and he has written an entire very big equation which contains d square y by dx square, which is a higher order derivative. Then this is dy by dx, the first order derivative, and then there is y. Now the conventional way is to get dy by dx, get d square y by dx square, put up in the equation the left hand side and keep on solving to get the right hand side. But that is a very lengthy process of getting the solution. So we are going to be smart and we are going to solve this question in a different way with a smart technique. So observe this and apply this technique to solve the rest of the problems also. Now take a look at the question. Now we have y is equal to e raised to m cos inverse of x. Obviously, to get d square y by dx square, I first need to get dy by dx. So let's first of all get dy by dx. Now I'm going to write y as e raised to m cos inverse of x. That's my first equation, isn't it? We have y is equal to e raised to m cos inverse of x. So I'm going to call it as equation number 1. Let's differentiate this both sides with respect to x. So when I differentiate this both sides with respect to x, I get dy by dx as. So what could be the derivative? So e raised to m cos inverse of x is like e raised to x, isn't it? So derivative of e raised to x is e raised to x, so e raised to m cos inverse of x, but it is not x, it is some function of x. So that some function of x should again be differentiated. So derivative of m cos inverse of x. So students, this is all concept of composite function. So make sure that you have watched all my previous videos on derivatives to understand all these concepts thoroughly. So now there was e raised to x, derivative is e raised to x, but this is not x, this is m cos inverse of x. So again I need to differentiate whatever is in place of x. So let's differentiate it. So I get m, which is a constant, and you all know that the derivative of cos inverse of x is minus 1 upon root of 1 minus x square. Now students, as you're watching these videos, I strongly recommend you that you should be knowing all basic concepts, all basic formulas very thoroughly. So make sure that you are already prepared with all those things so that it becomes very easy for you to understand all these steps that I do over here. Now let's move ahead now. So there is minus, I write minus, there is m, so I write m, isn't it? Now have you watched this term very carefully? It is e raised to m cos inverse of x. Look at this term. If you observe your equation 1 is equation 1, e raised to m cos inverse of x, which is y, isn't it? So I can replace this e raised to m cos inverse of x with y. So I get m into y upon root of 1 minus x square. Now students, you can get d2y by dx square by using the u upon v rule. But again, as I said, we are going to be smart. So let's transfer it on the right hand, the left hand side. Let's transfer this term which is on the right hand side to the left hand side. So I get root of 1 minus x square, I get dy by dx, and then I get minus of m into y. You can differentiate this equation, isn't it people? You can differentiate this equation. But again, I am going to be a little bit more smart over here, and what I'll be doing here is I'm going to do squaring on both hand sides. Now this will only ease out my steps, nothing else. Squaring both sides, isn't it? You can definitely differentiate this equation also. I'm going to call this as equation 2. So So either you want to differentiate equation 2, no worries, you can, or you can do this squaring both end sides. What happens? You get 1 minus x square, isn't it? And then you get dy by dx the whole square. There is a big difference between dy by dx the whole square and d2y by dx square. They are not same, people. This is a very important concept you should make a note of. d2y by dx square is definitely not equal to dy by dx the whole square. Let's understand this with an example also. If I give you y as sin x, if I give you y as sin x, then what is dy by dx, people? What could be dy by dx? So dy by dx is simply cos x, isn't it? So if I take dy by dx the whole square, that will be the square of cos x, that becomes cos square x. And if I ask you sorry, if I ask you to differentiate dy by dx one more time, d2y by dx square will be the derivative of cos x, which is minus sin x. That means for sure you can always say that d2y by dx square can never ever become equal to dy by dx the whole square. And this is true for any order of derivative and any power of derivative. Either it become the third order or the fourth order or the fifth order or the nth order. This is true for every single order of derivative. So I come back here, it was dy by dx the whole square is equal to negative square will become positive, m square and y square is what I'll be getting on the right side. So I write m square y square. And now students, I'm going to differentiate again. So again differentiate both sides. So what do I get when I differentiate both sides? There is 1 minus x square. It's a term of x. There is dy by dx. Now try and understand, since y is a function of x, dy by dx is also a function of x. So since y is a function of x, you treat it like x only. That means there is 1 minus x square. I write it as it is. Then there is dy by dx, which is something in x. Hide it for some time. Read it as u square. What is derivative of u square? The derivative of u square is going to be 2u. So I write 2 and this u, which is dy by dx. But students, it is not x. The derivative of x square is 2x. But the derivative of u square is 2u and again du by dx. So again the derivative of dy by dx becomes d2y by dx square. That's very important step, people. This dy by dx, you read it as u square, or you can say x square. What is derivative of x square? You write 2x. But is there x? No, there is not x. There is something in place of x. That something should again be differentiated with respect to x. So something was dy by dx. So again if I differentiate with respect to x, that becomes d2y by dx square. Then plus dy by dx the whole square as it is. dy by dx the whole square this time as it is. Derivative of 1 minus x square, which is minus of 2x, isn't it? Derivative of 1 minus x square, it is minus of 2x. Then equal to right hand side, there is m square. There is m square into there is y square. Now the term of y will be treated exactly like the term of x. The term of y will be treated exactly like the term of x. Since it is a term of y, I should always remember to write dy by dx ahead of it. So y square derivative is 2y and ahead of it I write dy by dx. Now look at the left hand side. Do you observe that 2 and dy by dx, 2 and dy by dx, one of the dy by dx from here can be taken out common. So let's take that 2 dy by dx common. What is left inside the first bracket or the first term over here? Inside the bracket, the first term is going to become 1 minus x square. 2 dy by dx has been taken out common. d2y by dx square, isn't it? Then there is a negative sign. So this plus and this minus multiplies, you get a negative sign. 2 has been taken out common. One of the dy by dx also has been taken out common. One of the dy by dx will be left and we'll be getting x dy by dx. That's the term left, isn't it? From the second term is equal to there is m square into 2 into y and dy by dx. Now from both sides sides, can you easily say that this 2 and dy by dx will get cancelled, isn't it? 2 and dy by dx both will get cancelled from either sides of the equal to sign. Now see the first term, what is left? 1 minus x square d2y by dx square. Look at the first term of your TPD, 1 minus x square d2y by dx square. Go ahead, do you see minus of x dy by dx? Look at this, minus of x dy by dx. You can see minus of x dy by dx. Can you see that minus of x dy by dx? Now on the right hand side there is m square y. The right hand side is m square y. If that m square y from the right hand side is transferred on the left, it will become minus of m square y. So see, the m square y transferred on the left becomes minus of m square y. That's your next term over here. There is minus of m square y, and the right hand side has now become vacant. The value there will be 0. So that is equal to 0. So that is how the problem got solved, isn't it? So this is one of the very important types of higher order derivatives. Make sure that you take your board textbooks very properly, find out all the questions of higher order derivatives, try and solve them very properly. Students, if you have any doubts regarding any of these questions, make sure that you write your doubts in the comment section below. We will make every effort to get back to you with the proper solution. Students, I hope you have understood this entire concept very properly of derivatives, all the concepts that I have taken, the derivatives, isn't it? All videos that I've made on single concepts of derivatives. Make sure that you have watched them all. You share all these videos with all of your friends. I thank you all for watching this video. Make sure that you share, like the videos. Thank you so much. Have a great day ahead.